This is 6.2.5. In here, we are given that xj omega is a periodic pulse, and that we have b equals to pi over 4. It means that it stretches from minus pi over 4 to pi over 4 with amplitude 1 for the pulse, and then it actually repeats every 2 pi. And it repeats every 2 pi because remember that we said that x of omega, the discrete time Fourier transform, is 2 pi periodic. We will now try to use the analysis equation to get back what is xn. And this is the synthesis equation. We want to use the synthesis equation to get back xn. We plug in x of omega from this figure. We are going to perform the integration from minus pi to pi, and this is relatively simple integration because x of omega only exists from this range, from minus pi over 4 to pi over 4 with a value of 1. So this is 1, and it goes from minus pi over 4 to pi over 4. And we can of course do this integration, and we get this expression over here, which is 1j 2 pi n ej omega n pi, so ej n omega, and we have this interval from minus b to b where b is pi over 4. Now we get this sine function, and then later on you convert into the sinh function. Now there's no mistake, the sinh is of k is defined as sine of k times pi. So the sinh introduces a pi inside. So you are given k, and then there will be a k times pi divided by k times pi. So what about sinh of bn over pi is sine bn over pi times pi. So the new pi is introduced, and then we divide by bn over pi times pi. So pi is cancelled. So this is the sinh function. Reduce, and then we are multiplying by b over pi. So b cancels, and then we are left with sine bn over n pi. And isn't this exactly the same as sine bn over n pi? So this expression, this change of expression from sine bn over pi n equals to this expression is a very standard conversion. Now, so this is x of n. And then we of course need to substitute for different values of n. And here we start from 0, and this is n equals to 1 and n equals to 2. And if you substitute these different indexes of n, you'll get this sinh function out here. Remember, we are not supposed to substitute anything between 0 and 1 because n belongs to an integer. N must be an integer because we are in discrete time. And of course, if you can go ahead and substitute n equals to minus 1 and so on and so forth, and you'll get the other side. Okay, and you'll realize that xn is not periodic. Okay, but it is a discrete time because we are in index value of n now for time. And this is the final answer. Alright, go ahead and try to write the synthesis equation using this equation and by plotting this function out. Thank you.